Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. That to the issue of time series modeling. In the earlier lectures, we have already discussed various time series modeling, starting with the autoregressive, moving average, ARIMA, then arch cluster, gauge clusters, and today in the similar flow we will continue with another cluster, that is what technically called as VAR modeling, and it is simply the scheme of vector autoregressive. We have already discussed a concept called as autoregressive modeling in the case of ARIMA cluster, but here the additional component is the vector part, and as a result the particular structure will be vector autoregressive modeling. So, that means it is the cluster of at least two different variables with time series structure. That is what the technical things to start with this particular engineering problem. So, what we like to do, we like to highlight actually the concept of VAR modeling, and that too where the situation arise when there are two variables and we like to predict whether they are predicting each other or not. Of course, we have discussed this issue, but now we like to discuss in a kind of time series framework. For instance, two kind of variables, let us y and x, then we are usually interested to know whether x is causing y. That is what we have already discussed in the framework of simple regression modeling. So, by default we will link like this y equal to function of x, where x may be a vector and that too it represents like series of independent variables like x1, x2 and x3. So, x1, x2, x3 are series of independent variables, and that too y is the dependent variables. But many occasions what we find actually, so the y and x can be connected with the same causality approach, but with a time series angle. So, here the basic idea is that we like to check whether x is influencing y and at the same times y can influence the concept x. So, technically in the VAR setup we like to test for different hypothesis. For instance, first hypothesis is whether x causing y, and second hypothesis will be, let us call it H10 and this is H20 where y causing x. Okay. So, that means technically we start with the first with the issue that x can influence y, and at the same times we can say that y can influence x. There is a high possibility the first hypothesis will be true, the second hypothesis not, or the other issue will be the second hypothesis will be true, we can validate the second hypothesis, but first hypothesis will not be in the picture. And in the third instance both can go simultaneously, and the final one is both may not go together. So, that means they may not cause each other. So, that means technically we have three different inference. The first one, there is no such causality between y and x. Second instance, there is causality, but it is the approach of unidirectional, where either x causing y, while y does not cause x, and in the third case we can have both, y can influence x and x can influence y. That is what the technical concept called as bidirectional causality. So, technically we like to check which one is the correct ones, whether it is actually x causing y or y causing x, or they cause each other or they do not cause each other. That is what the basic framework of VAR modeling. So, what we used to do, that we like to know the technical issues of VAR modeling while addressing the causality between two variables y and x, that to check whether x causing y while y does not cause x, and at the same time we like to check whether both cause each other or they do not cause each other. That is what the basic background, and that too we have a kind of time series framework. So, the beauty of the VAR modeling in a bivariate framework is like this. So, technically it can be set equation like in such a form, that means with the help of log modeling, because this ARIMA cluster, ARCH cluster, GACH cluster, then VAR cluster, all are started with the kind of log involvement. So, now we like to check in the framework of VAR modeling how is this particular linkage. So, the linkage will be like this. So, we can start with say y t is equal to function of let us say alpha, okay, then plus summation beta I y t minus I equal to 1 to p plus summation delta j x t minus j and j equal to 1 to q plus the error terms. Okay. So, that is what the first model, and so that means we like to check two different hypotheses altogether. The first one is whether x causing y and the counterpart will be y causing x, and this framework will take you into three different paths. So, the unidirectional path, bidirectional path, and then neutrality path, neutrality path. Okay. So, then the thing is that in the unidirectional path, so if x causing y, so y does not cause x sometimes, or y can cause x, but x does not cause y. That is what the kind of structure. And in the same times, in the case of bidirectional path, where y influence x and at the same times x influence y, both will go parallelly. But in the case of neutrality expectations, y does not cause x and x does not cause y. That is what the kind of game altogether. So, now we like to check which one is the correct. That means all cannot go simultaneously. If it is neutrality, then bidirectional is not possible, or unidirectional is not feasible. If unidirectional feasible, then either these ones or these ones. However, if both will cause each other, then that means technically we are here. So, that means in total we may here or we may here or we may here, that is what our the expectation, and VAR is such a technique which can derive such kind of inference. The variable may be any kind of engineering variables, that is not big deal, but the structure of this problem is like this, and to test this we have to design a framework like this, and this model is to test whether x causing y. So, technically this kind of models y t as a function of log y t and log of another variable x t. So, that means in simple form we can call y t as a function of y t minus I and x t minus j, that is what the framework. Now, transferring into a particular explicit form, the model can move into like this, where the null hypothesis is that the delta j should not equal to 0, where j equal to 1 to p, and the alternative hypothesis will be delta j equal to 0. Okay, so, you can start delta j equal to 0 against delta j not equal to 0, where j equal to 1 to, so like this. So, that means technically we like to check whether these coefficients are coming. Okay, so this should be equal to 0 against this not equal to 0, that is what the null hypothesis. So, now in the similar way we can write here another equations where x t as a function of x t minus I and y t minus j. If we write like this, then that brings the causality between y to x. Now, we like to check whether both are correct, where we are rejecting the delta j for both the models. If that is the case, that is what called as bidirectional causality. If not, then either the first one is true, the second one is rejected, and second one is true, first one will be rejected, and then finally both can be rejected. That is what the case of neutrality hypothesis. So, now before we come to this VAR setup, to bringing or to know the influence of x on y or y on x by the framework of log modeling, we like to check some of the basics, that is what called as stationarity check and the kind of cointegration check. Usually in the time series framework we have a concept called as short run structure and the long run structure, and VAR will bring that particular structure to highlight whether there is a relationship between y and x, and that too whether in the short run or in the long run. So, to start with this VAR modeling, we have to first highlight the concept called as a unity root and the concept called as cointegration. So, before we analyze the VAR modeling, so we should know what is actually the unity root concept and what is the cointegration concept and how it is linked with VAR modeling. So, until unless you know the unity root and cointegration, you cannot specifically use or utilize the VAR model to address the causality between two variables with reference to this kind of structure, let us say y and x. So, let us see how is that case. So, in such a situation, what we like to do? So, we like to bring the concept of unity root and cointegration. So, let us know what is actually unity root and cointegration, and then we will discuss the VAR modeling. So, somehow unit root is slightly touched in the case of ARIMA models, where we use the term autoregressive integrated moving average. The term integrations there itself is a influence of unit roots only. So, unit roots literally means to check the testanarity of the variables, and testanarity represents the stability of a particular variables. Usually, we like to check or we like to use a particular variable to study the influence, where the variable by default is a stable one. But in any sense, we are not going in deep about this theoretical understanding about the unit root and cointegration. However, we just like to know what is the concept of unit root and how we can actually check the unity root, and that too as per the requirement of VAR modeling. So, the test which we can actually do for unit root, that is called as unity root test, and the objective of unity root test is to check whether the variables are testanary or non-testanary. If non-testanary, at what level the variable will be testanary. So, that means here we have to bring various levels where the variable will be stable. So, starting with the original form, the first difference form, the second difference form, and so on. For instance, if a variable say y, then its original form we declare as y t. So, it will be like this, it will be called as y t. So, that means in data set we have a t corresponding to y informations. Now, we have the term called as a delta y t, which is nothing but called as a y t minus 1, that is the difference. So, t minus 1 means if I use y t and this y t, so we can call it y t, then by default y t minus 1 will be just 1 lakh behind. So, if this series starts here corresponding to this y t, then y t will be just 1 lakh behind. This is how the series will be generated. Then we can create a component called as a delta y t by making the difference between the two, and then we will get a new variable called as a delta y t. So, delta y t equal to y t minus 1. Now, in the similar way we can create delta square y t, which is equal to delta upon delta y t. That means, we have already delta y t here. So, that means technically it is nothing but actually delta y t minus delta y t minus 1. Okay. So, then we will simplify, you will find y t minus 2 y t minus 1 plus y t minus 2, like this we will have a similar kind of structure. So, like this you can increase the order. So, the delta is called as first order difference operator, and that is why we like to bring original form, first difference form and second difference form. This is what it is called as variable in its original form. This is what called as variable in its first difference form. This is called as a variables with reference to second difference form. We can also equally like you can write L y t. So, log of y t. Okay. We can call g y t, growth of y t. So, like there are various ways of addressing the variable, that is called as transfer form, and we like to check actually what level the variable is bringing actually its testanarity. So, that is how we are checking the unity root. The standard standard form is actually to check yt, delta square yt and so on. So, that means the degree of movement. So, if the variable reaches stationarity at its original form, that is at yt, then by default the order of integration is 0. If the variable reaches stationarity at the first difference, that means technically here, then the order of integration we call as I 1, here it will be I 0. If the variable reaching stationarity at the second difference, that means here, so then the declaration is called as I 2. So, like this we like to know what is the bracketed term is called as a order. So, what is the order of integration through which we can declare that variable is stationarity, variable is stationary or reaching stationarity. So, that means technically the form where the variable is actually reaching stationarity, that is the form we can use in the VAR setup. That is what the big deal in VAR modeling. So, we have plenty of test that to conduct the unit root, starting with decupolar, that is called as a DF, and then little bit advanced, that is called as a augmented decupolars. Then we have plenty of other tests like Phillips Perron, KPSS, Andrews-Iver test. So, likewise we have actually series of unit root tests, and more or less every test will give you similar kind of inference. If you use ADP and declare the variable is having order of integration 1 I 1, that is the order of integration, and then the variable will be declared as stationarity, where the order of integration is 1. Again, if the variable reaching stationarity at I 2, that means the order of integration is 2. So, the same inference you can also get through other unit root test statistics like Phillips Perron's, KPSS, Andrews-Iver. Okay. Like there are so many other tests as well. So, in any case we can use at least 1 or 2 tests minimum to check what level the variable is reaching stationarity. Okay. So, this is the first part of the game, and in the second part of the game we like to know whether the variables are cointegrated. So, that means the starting of the VAR model at least with 2 variables, like we start with simple linear regression modeling, that will linear regression modeling with respect to y and x. Here the starting is also with respect to 2 variables y and x, compared to simple y. Still we can have regression, what is we have discussed in ARIMA cluster and ARCH cluster and GACH cluster, but in the VAR setup we need actually at least 2 variables, and then we bring their lags, and by default like ARIMA cluster and ARCH cluster and GACH cluster, we need to first optimize the lag length. So, like we have already highlighted the big model, where y t as a function of y t minus j or x t minus j, the lag creation. So, obviously you have to first specify what is j, that is the optimum lag. If say j equal to 1, then the model will be restricted to y t as a function of y t minus 1 only. If not, let us say j equal to 3, then y t will be influenced by y t minus 1, y t minus 2 and y t minus 3. So, that means at a stress 3 lag can influence the current y, and sometimes it is true. For instance, the investment in infrastructure, investment in transportation. So, the past year transportation will bring transportation output today. So, now the question is how many past you have to consider for today's transportation outcome. Let's take any simple civil engineering problem. So, the past investment will bring the current performance, and in this kind of framework. So, the VAR is the supreme, and VAR can do that and detect up to what lag or up to what position the past behavior or past reaction of the variable will influence the present behavior. And for that we need to know the tesonarity issue and the cointegration issue. So, we first do the unit root check, since the game starts with two variables y and x. So, first thing is you check what is y order of integration and x order of integration. Since it is a vector autoregressive, so you can have a more number of variables into the system, but let us understand the bivariate structure, then you can go for a multivariate structure. So, coming to the cointegration, you first need to check what is the unit root position between y and x. We need to report whether they are having same order of integration to reach the tesonarity or different order of integration to reach the tesonarity. That brings the difference, and that brings difference in modeling, and we need to have that information before you start the process. Cointegration simply represents the issue of long run relationship between the two variables. There is a high chance in the short run, in short span of time, the variables may not have any kind of linkage relationship, but over the time they can converge each other, they can cause each other. That is technically called as cointegration. So, they are in a different position in the short runs, but ultimately they will converge each other in the long span of time. And the technique cointegration we like to check whether these two variables will be converge each other over the period of time. If that is the case, then we can use say vector order regressive. VAR has a two form: simple vector structure, vector order regressive. If not, then there is a counterpart called as vector error correction modeling. So, there will be error correction term which will be representative to know the long run impact, and the difference between VAR and VSM will be coming into the picture with reference to cointegration only. So, that means it is a mandatory requirement that you should know what is unit root position and what is the cointegration position before you start estimating the VAR modeling and look for the kind of inference. Until unless you know the structure of unit root and cointegration, you are not in a position to go for, estimate the VAR modeling. But we should know how is this setup actually in the case of unit root. So, let us take an example here. I will take you to the Excel spreadsheet and see here. Here it is a time series data, and we have here data with respect to different time period, and that to monthly data, and we like to regress inflation with oil price, and the first component is inflation, which is its original form we call it inflation and or INF, or we can call INFT, that is the original form, and then we can create actually INFT minus 1, just one lag behind. This is the series. So, just copy and one paste one lag behind, and that will create a new variable called as INFT minus 1. Similarly, this is actually oil and it is called as OT, and then this is T minus 1, this is the lag variables, first lag, and again corresponding to inflation you paste 2 points behind, then it will create the kind of inflation T minus 2. Again similarly oil T minus 2, that is the after pasting 2 points down corresponding to oil data. So, now you can check unity root at this stage, that is called as first level check, and that is the variables in its original form. And if you check these two variables at this stage, this is another case. Okay, I will make it different color. So, this is the variables, and we are checking these variables at their first difference. Okay, so, T minus 1s, and then we can bring the difference, and again we can check with the 2 lag. Okay. Now, what is happening? So, now to bring delta INFT, so this minus this, so you can create delta INFT, so that is the first difference. So, likewise you can actually create delta YT minus 1, similarly oil T minus 1 and delta oil T, like this, and then you check their unity root separately, and again you can do through software only, particularly using the decupolar test and augmented decupolar test. The model is very simple one. Okay, just you connect with YT upon YT minus 1, like a simple we apply in a kind of mean equation in Gauss model, and that will bring the structure of the kind of unity root. And again if you apply augmented decupolar, some extension has to be added, and some of the softwares by default will give you the results of DF, ADF, PP, Phillips Perrons, KP, SS, like this. So, just use the software and allow the software to detect the order of the integration of a variable where it reaches stationarity, and that is the first hand information we need to report before we start cointegration and then the VAR modeling. So, this is what the procedure you have to follow, and then check the stationarity part first. After checking the stationarity, then you have to start linking these two by cointegration framework. So, we should know how cointegration can be applied to explore the long run relationship between the two variables or group of variables. So, first unit root, then cointegration, and then VAR. So, that is what the steps we have to follow. So, I have already highlighted the unit root structure. Of course, I have not discussed the details about all these tests, but somehow I have named this test. So, you can use any test, then check the stationarity of the variables, and that is the first step of this process. Once you do that, then we can move to second step and the third step. So, in the next lectures we like to touch upon the second step and third step, where we can know about the cointegration and the VAR structure. With this we will stop here. Thank you very much.